Hi, everybody. I would like to introduce a new topic today, the rank of a matrix, which is used by linear algebra. And also in some cases, it's used by other sciences also. So today we are going to find the rank of a matrix with size 3 by 3. So rank of a 3 by 3 matrix. So how we can write it? A is equal. Let me explain what's the rank first of all. So A is equal. Let's take such a matrix, for example, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Let's take such a matrix. So in our case, if you know what's the rank for this matrix, the rank is that it is the number of linearly independent rows or number of linearly independent columns. So for example, we have got 3 here. You see 3 rows. So it's obvious to think that the rank will be less than or equal to 3. So it can be 3, it can be 2, it can be 1 also. There is also the 0 rank case. The 0 rank case is when all the matrix has got the 0 elements. So today we are going to discuss a new method, which is called minor method. How to find the rank of such matrices. So we are going to use here vanishing minor methods. So what's the idea of this method? The idea here is that we take 1, 2 by 2. Let's take 1, 2 by 2 minor. For example, m. Let's denote it by m. M is equal, and we calculate the determinant 1, 2, 4, and 5. So you can see here, if you calculate the determinant here, it's going to be 1 times 5 minus 2 times 4. It's cross. So it's going to be minus 3. Yes? 5 minus 8 is minus 3. It's not equal to 0. So we are interested in minors which are not 0. Yes? So minor here is not 0. So we can use this minor for our calculations. And in this case, rank can be 2, but we don't know exactly it is 2 or not. We are going to check it. In order to check it, we are taking a bigger matrix, a bigger minor, yeah, which has got this minor in it. So the minor which covers all these 1, 2, and 4, 5 is the determinant of A itself. Yes, so determinant of A, you can see it is 1, 2, 4, 5. So we have this minor inside of this bigger determinant. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So obviously you can see our minor is here inside. So we are interested in the numerical value of this determinant. Let's calculate this determinant. Determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know from our previous lectures that in order to calculate this 3 by 3 determinant, we can apply different methods. Yeah, and one of the methods is that we use as a Sarus method. So it's the idea of this method is like 1, 2, 3, 4, 5, 6. 7, 8, 9. So we put two columns next to our determinant. So what we do next, we are going to do the positive signs. Yeah, it's going to be something like this. So it's positive. It's positive again. It's positive, yeah. And we are going to have the negative signs. Negative sign. So let's calculate it. Let's do our calculation. So first of all comes the positive sides. So 1 times 5 times 9. Yeah. Let's write 1 times 5 times 9 plus 2 times 6 times 7 plus 3 times 4 times 8 minus again 2 times 4 times 9. We pass to the negative factors. 2 times 4 times 9 minus 1 times 6 times 8 minus 3 times 5 times 7. Let's calculate. It's interesting for me. Are we going to get here 0 or not? So 1 times 5 times 9 is 45, plus 2 times 6 times 7. It's going to be 84, plus 3 times 4 times 8. It's how much? It's going to be 96, yeah? Minus 2 times 4 times 9, yeah, 72, minus 1 times 6 times 8. It is going to be how much? We know that it is 50. Yeah, it's 48. Minus 3 times 5 and times 7. It is 105. So let's calculate it. 45, 45 times 84 times 96. If we add these 3, how much we are going to get? Let's calculate it. 45 plus 84 plus 96. By adding and subtracting, we are going to get, yeah, it's going to be 225 minus 72 minus 48 minus 105. Yeah, it's going to be how much? 0? Yeah, so we are sure that we get 0 here. What does it mean? This determinant actually is equal to 0. So from this overview, we get that the determinant which covers our small minor is equal to 0. So what does it tell us? According to this minor method, then the rank is 2 here, because it's the non-zero determinant here, and its size is 2, so it's 2 by 2. You know, it's 2 by 2 matrix, so that's why the rank is here is 2. Hopefully that was, we are going to continue this topic, by the way, in our next videos with higher determinants, preferably 4 by 4. We are going to show it here how to find it, but it's not important. You should be aware that it's not important to have the square matrices here. It's not important. Let's see one more case where the matrix is not square, yeah? For example, let's write such a matrix. A equals 2, 3, 6, 1, 4, 5. Let's find the rank of this matrix. Again, what we do, we are interested in one minor. We can take any minor. For example, we can take this minor here, or we can take this minor here. So that depends on our selection. So let's take this minor. Minor is equal 2, 3, 1, 4, which is 8 minus 3 is how much? 5. This is not 0. So we are interested if we have any more bigger size determinants which cover this minor. Obviously, you can see that there is not a bigger size determinant. So the only bigger determinant here is 2, 3, 1, 4, or size 2 determinant. So it tells us that if this is not 0, then by this method it says that the rank here, the rank of matrix A is 2, because 2 by 2 gives us non-zero result. Hopefully you enjoyed these explanations. I'm going to add here some more videos. Do not forget to subscribe to the channel to get more and more videos. Thank you for watching. Take care.